From the discovery of a new planet light years away to new missions to our next-door neighbor. What's the latest in the exploration of space? And is the universe big enough for the space tourist? This is Inside Story. Hello, I'm David Foster. It's a tiny spot in the universe that scientists are marking with a big X. Could it be that European astronomers have found another planet besides our own that can support life? When light can travel 8 times round the Earth in just 1 second, is it possible to imagine something so far away it would take light 20 years to get there? This planet, scientists say, is the most Earth-like object ever discovered to date. They think it may also have water running on its surface, and if there's water, there could be life. Scientists believe the planet's temperature hovers somewhere between 0 and 40 degrees centigrade, and it's either covered with rocky terrain or oceans.
It's the smallest planet yet found, the one closest to being like our Earth, but it's still 5 times heavier and probably half again as big.
They didn't find this planet with a telescope. They used an instrument that looks for stars and then tracks how fast they move. If they pick up a change of pace, it indicates a planet is tugging on the star's gravity. And that's what's happened in this case. They came upon a so-called red dwarf, which led them to this new planet.
Red dwarfs are the most common variety of star. There's, depending on how you count them, there's certainly several hundred billion, as Carl used to say, stars in our Milky Way galaxy. The vast majority of them are red dwarfs.
And it seems at least one of those billions of red dwarfs is playing host to a planet like our own. Could it be the only one, or are there more? Well, joining us now to talk about this is the lead author of the research paper about this new planet. Stéphane Udry is an astronomer from the Geneva Observatory in Switzerland. I know you're very excited about this. How long ago did you realize there might be something special out there?
Good evening. First, you do not realize it just in one spot. You follow the star regularly to measure the velocity of the star, and when you are able to characterize the system, you see, oh, the planet should be there. And in that case, what was even more exciting is that the period of variation tells you the separation between the star and the planet. And the separation was just right for the temperature on the planet to be about 20 degrees. And so to allow the presence of water potentially on that planet.
You don't know at the moment whether it's got water. How are you going to find out if that is the case?
Wow, so that's a difficult question. On the long term, there are projects of space satellites that should be able to hide somehow the light coming from the star. And then you will be able to see the light coming from the planet. And at that point, you can start to analyze the chemical composition of the atmosphere of the planet. And then you will be able to see if there is water, and even if there is traces of oxygen. And on Earth, the only way to have lots of oxygen in the atmosphere is having life. So with those projects, we even could know if there is life on that planet.
So you don't even need to go to this planet, which would take thousands of years at the moment. You can do it from where you're sitting at the moment.
Yeah, astronomers are doing that since centuries because stars are so far away. Even that one is very close to the sun, 20 light years. It's one of the 100 stars the closest to the sun. But even going at a speed that would be 1/10 or 1/100 of the speed of the light, that is the limiting speed, we know that from physics. So you would need centuries or thousands of years to go there. So it's hopeless.
In terms of the size of the planet, that's pretty crucial to your research as well. You were looking for something that was quite small.
Exactly. What we are measuring is the mass of the planet. So we know that the mass is about 5 Earth masses, but then models of rocky planets are telling us if the mass is 5 Earth mass, then the radius has to be something like 1.5 Earth mass. So the planet is just a bit larger than the Earth, but not that much.
In terms of its radius, I gather it's about half as big as the Earth, which obviously increases the mass disproportionately. If it's too big, it just turns to gas. Is that right? This is the only way that you can get a solid substance in space if it's a particular size?
Yeah, during the planet formation, if you build a too big planet, let's say 15 Earth masses or 20 Earth masses, then the planet will start to accrete gas very rapidly, and then you end up rapidly with a Jupiter-type planet.
Remind us of the name of this planet.
We don't give real names to the planet. We are just using the name of the star, and we add a small letter after it, B, C, or D, in order of discovery of the planet. In that case, that's a three-planet system, in fact. And the first planet was detected 2 years ago, and now we are announcing 2 other planets. The third one is also very interesting because the mass is only 8 times the mass of the Earth. So it's not that bigger than the small one. And so the small one in the habitable zone would be Gliese 51a(c), Gliese 51a being the name of the star, and the outer planet is Gliese 581d.
Stefan, I know you deal in fact as much as you can, but do you ever sit down and wonder, if there is life out there, if there is water, I wonder what sort of life there really is. Could there be life like ours?
It's a very difficult question because it's speculation, but we know several things already. If you want to build life, you need oxygen, carbon, nitrogen, and all these chemical components are all formed in the stars, into stars. So they should be available everywhere. That's one point. The second point is that if you look for living creatures on Earth, the biodiversity is very large. You have, in very special environment, you are finding bacteria, for example. So anything from bacteria to big fish could be on that planet.
So you don't think they're out there watching us, watching them?
That's a really difficult question too, because then you have to go to the next step, to the intelligence. And if we are pretty sure that life is developing in many places in the universe, for intelligence it's a bit more difficult. I would hope so.
Stefan Udry in Geneva, in what looks like a rather more hospitable place than the one in which I'm standing at the moment. Thank you very much indeed. We're transporting ourselves away for a few minutes now. When we reappear, we'll be looking at men on Mars and space tourism.